Well, today I wanted to cover a topic that I've been meaning to cover since I uploaded the very first video on this channel, and that is concerning these. Now, if you haven't already guessed by now, these two things right here are the CPU pots, which I have made myself for the purposes of getting into extreme overclocking. And the primary reason why this video got delayed for so long was because I wanted to have a second functional CPU pot before I made a video reviewing my very first one right here. And then that got delayed even further up to this point, as there are some problems with this one, which we will get to in a bit. I would also like to clarify right now, this video is not a guide on how to make your own CPU pot. I will be talking about the construction, but an actual guide video will probably be something I make in the near future, and I'll probably have several videos exploring different ideas as I try to make better ones. This also brings up the question as to why make your own CPU pot. Sure, a lot of people have done it if you actually go online, find some extreme overclocking sites, such as Extreme Systems or overclockers.net, or where I found the primary idea I'm leaning to was actually on the EVGA forums. And I'll actually put a link in the description below to that, to where I got the primary idea where to make this one and where I'm going to make the next iteration. And as far as the reason as to why make your own CPU pot, well, first off, there's budget. Like CPU pots, if you've ever looked at the pricing for them, or at least the good ones, they are typically somewhere around $300, $400. And let me just tell you right now, neither of these, even though I haven't calculated the exact cost way less than that. There's also the ideas of just kind of craftsmanship and pride. Like, you make these yourself, you really get kind of connected to them. Even this one, which is the junkiest one that I've made and looks like an abomination from overclocker's hell. Looking at it, I'm still really proud of making it, and it was a great learning experience all around. With that, let's look in closer detail to these both of these pots individually. Okay, here we are with the two individual pots, and even though it seems a bit cheesy, I did name these. This is the Baron Mark 1, and this one, if you haven't guessed, the Baron Mark 2, since it's the second one I made. But for now, let's just focus on the first one. And you've probably noticed, especially with these closer up shots, that the side of the pot and the interior is not too much different, are very rough looking. And that's because this has been cast out of a single piece of aluminum. This was cast using what's called sacrificial foam casting method. And since it's solid aluminum, the mass ended up being very low because of how much I could carry in a crucible to melt and then pour into a mold. This weighs about 0.9 kilograms, which is just about 2 pounds even. And it has some holes for surface area, but since this was cast with the walls, it meant I had to drill the holes at the bottom there with this intact, which was quite troublesome, as I need a long drill bit just to drill some holes. But this pot has proven to be fairly nice for starting out and really got me into it. And with the Baron Mark II, as you can see here, this was a lot more complex to make, and when I made it, I was hoping it would be a CPU pot that I could just kind of stick with for the rest of my life. It was not that simple, though, after construction. So first off, going to the actual construction, this is solid copper on the outside. This is a 2.5-inch copper pipe, which is kind of a specialty item to buy, but you can get it. And then this is a 2.5-inch copper couple for the piping. I did have to file the inner parts of these indents. The inner parts of those I had to file off, and that allowed me to fit this all the way up the pipe instead of having it stopped halfway. And then this bottom part here with that nice shiny mirror finish, that took a while to get, that is solid brass. I'm just kind of calling this the CPU pot core, and because that's the main mass and it's also the main surface area. Even looking inside, there's a lot more holes in there. Those were still kind of hard to drill, and I also ran into a couple air pockets in the casting, so some of the holes came out kind of rough. And this is the pot idea that I got from the EVGA forum. As I'll say again, it's down in the description below. if you want to look at it. So this is not my idea originally. I had a similar idea to this using copper piping and then having an end cap, and I thought that seemed so original. But it turns out a lot of people had already done it once I started doing some research. But as I've said, this pot does have some problems as well as the Mark 1, and so we're going to get into that next. We'll start with the Mark 1. The first problem that came up was during the actual casting. This required 2 attempts at a pour. Having these relatively thin walls to cast that are very tall, again, relative to casting in sand like I was doing, that is actually fairly difficult to achieve. I was actually surprised I was able to do it on the second pour so well. The first time the walls just collapsed and ended up as a giant lump of aluminum. But the bottom part did come out fairly clean. It ended up kind of expanding in the sand, probably because of the weight of this. Overall, it's a very crude construction, and I didn't even bother polishing up what I'm just going to call the contact plate. I didn't bother polishing that up or surfacing it very well. It's just flat enough that it was making enough contact to function properly. The other problem with this, again, kind of to the limitations of the crucible I was using, I couldn't hold that much aluminum. This isn't like the total amount of aluminum I can hold, but it's pretty close. And that meant I couldn't make these walls too tall. So the actual pot area is only about 3.5 inches deep, which means once you put a bit of solvent in there and then you start putting dry ice, it fills up very quickly, but it goes away very quickly. So you couldn't really just put dry ice in and leave it as I would have liked. So that kind of was one of the key points that I really wanted, kind of a quality of life upgrade for the next iteration. So with the Mark II, this was not actually the first design that I was trying to do when I was trying to upscale from this. The original idea was to replicate this, but do it with, well, 2 changes. 1, it would be made out of brass, and 2, it was going to actually be 2 sections, the wall section and then the base section. And that would allow me to make the wall a lot taller, since I could hold enough metal for that pour in the crucible. And then the second one would be on its own. I was only able to make the base successfully out of brass. Like I've said before, the walls can collapse since they're actually relatively complex shape for casting, and what it ended up taking was 7 failed attempts of making the walls after just 1 successful attempt of the base that I decided I needed to switch to a different idea. So this idea out of the picture, I came across this idea in the, wow, I said idea a lot. Anyways, I came across this inspiration, shall we say, in the EVGA forum, link down below, and it turned into a huge disappointment. And one of the results of how I designed the Mark II over the Mark I was that it is much, much heavier. The Mark I, which is off frame there, as I said before, it weighs just about 2 pounds, which is 0.9 kilograms. This weighs 6 pounds, which is about 2.7 kilograms. And that's a big improvement, or at least it was supposed to be. I had hoped that that key factor would just allow me to pretty much bench everything at an extremely low temperature consistently, and that went wrong very fast. Right off the bat, as I was trying to replicate the overclocks I was doing on my Xeon X3450 system, that just was kind of my baseline for testing to see how good of an improvement it was. The temperatures were swinging way too much on the CPU. I could have real temp open, and then I would run Cinebench at 4.6 gigahertz, and the CPU temps would actually hit 30 degrees Celsius, and the pot would kind of raise in temperature. At least the thermal probe at the bottom was reading an increase in temperature, but not that big of a change. So that of course tells me that for some reason it's not transferring heat from here to the CPU, or I should say from the CPU to the pot well enough. So at first I thought it was a thermal paste problem, because I do use Ceramic 2, which is supposed to be a good budget thermal paste for extreme overclocking. I have actually found that using MX2, at least with dry ice, did work very well. I think I'm actually going to be switching to just using MX2 for all my dry ice overclocking, because at the temperatures you get with dry ice, you don't need to worry about thermal paste cracking really. So as long as it has high thermal conductivity, it should work, and MX2 does fit that bill, and it's cheaper than MX4 without being too much of a difference. And in my my kind of self-testing, just for my own purposes, different thermal paste thermal conductivities, ceramic is actually really, really bad. It's about kind of the same as kind of these bulk tubes of thermal paste that you can buy for like $2, and I use this just for like pre-testing stuff to make sure it works because it's cheap. And ceramic's about that bad. Now the other problem that I thought it could be was the actual contact between the CPU IHS and the contact plate for the pot. So of course I went ahead and polished the entire surface of this. It's now very shiny, as you can kind of see. That ended up not making any changes, and I tried to make sure that I was contacting the CPU IHS. I did some light lapping on the CPU to try to level it off, which actually didn't seem to really make a difference to how the surface of it looked. So then I came to kind of a realization, and that is from the lack of research. And what did I not research properly, you might ask? Well, it turns out metals. So you see, most CPU pots, in fact pretty much all the ones I've ever heard of, are made out of copper, and that's a very good thing. Copper has a good combination of thermal conductivity, mass, and specific heat that just make it really good material to make something like this out of. The first pot I made is aluminum, Baron Mark 1. Now just as a comparison, copper has thermal conductivity of about 386 watts per meter Kelvin. The aluminum that I made this out of, which is not pure aluminum, it's some alloy, but aluminum has approximately thermal conductivity of about 204 watts per meter Kelvin. And that brings us to the Mark II and why it's such a problem to have and use. The main part of this is brass, and brass, being 75% copper, I thought would be somewhere in between aluminum and copper. But I guess the zinc changes it quite drastically, because brass of about a 3-to-1 ratio of copper and zinc has thermal conductivity of about 111 watts per meter Kelvin. That is almost half of the aluminum, and like, what would that be? Between a third and a fourth. What? Anyways, copper would be somewhere around 3.5 to 4 times more conductive than the brass that I used here. So yeah, the kind of lesson to learn from this is do your research before you start a project, especially something like this. Like, it seemed relatively simple to me, and I was more concerned about the physical design of both of these pots than the actual material. I just kind of thought, well, this metal should be close enough. Not that I actually knew what the properties of any of these were before planning out this video. And that brings us to what the future plans are for my CPU pot. Obviously, I'm not sticking with either of these because they both have their issues that are actually both fairly detrimental, as good as they were for starting. But my next step, and I'll probably be actually starting on this later this week, is to disassemble this, because I do plan on using this pipe and this couple. I'm going to remove that core out, and then I'm going to cast a fully copper one, and then it's going to take its place. That, assuming I do it correctly, and I am going to take more care with drilling the holes inside, not that you can really see those on camera right now. If I make this pot out of copper for the next version, it should be a CPU pot that I'm pretty much happy with for the rest of my life, unless it just suddenly doesn't fit because IHSs get 4 times as large because AMD and Intel keep putting more and more cores.